Hello, good morning, and welcome to the next lecture of our DBMS series. Today we are going to convert ER diagram to relational schema. So first we have to convert ER model to logical database design, and this logical database design is the process of converting the conceptual model into an equivalent representation in the implementation model. It can be anything. It can be means relational, hierarchical, and network. While we will focus on the relational database design, so convert ER model into relational schema, and there are well defined rules for this conversion. First we will take the strong entity types. So each entity type becomes a table, and each single valued attribute becomes a column. Derived attributes are ignored, composite attributes are represented by components, and multi-valued attributes are represented by a separate table. The key attribute of the entity type becomes the primary key of the table. So we have employee a strong entity type, and it has various type of attributes. Like address, it is a composite attribute. Year of service is a derived attribute. Skill set is a multi-valued attribute. So what we will do, number, employee number is the primary key, so it becomes the primary key. Name, door number, stream, address is the composite, so the components of the address will become the column of the table. And date of joining, while year of service is a derived attribute which we will ignore, and skill set is a multi-valued attribute, so which becomes the another table, and employee number will becomes the foreign key of that particular table. You can see employee table, and in skill set employee code is the foreign key for the to establish the relationship between employee table and skill set. Converting big entity types, whenever we have big entity, so what we will do, we will create another table of big entity, and the primary key of the identifying relation will become the part of the primary key in the reference relation, means independent. So here dependent is a big entity. Dependent doesn't mean anything in to the problem without the information on for which employee the person is a dependent. So by which we have to create the separate table with identify the primary key of the identifying relation as a part of the primary key. Here you can say employee code is also is the prime part of the primary key, as well as working as a foreign key plus dependent ID. Then converting relationships, we have possible cardinalities is 1:1, 1:m, and m:(n), and the degrees of the relationship are unary, binary, and ternary. So first we are taking binary 1:1, where employee head of department is a 1:1 relationship, and department is participation total while employee is participating partially. So in this case total side have the foreign key from the partial side. So employee number will become the foreign key in the department table in the name of head. You can see this employee table, department table has a column head, and where the employee code will work as a foreign key. Another 1:1, where is uniform participation types, employee sits on chair, so it is 1:1. In this type of scenario, any primary key can become the foreign key in another relation. There is no problem. So employee number can become the foreign key in the chair, or chair number or item number can be become the foreign key in employee relation. So here you can see both are possible and both are correct. Then binary 1:n, teacher teaches subject, so it is 1:n relationship. In this type of one type one type of entity becomes the foreign key in the n type. So teacher ID will become the foreign key in the subject ID. Here you can see the teacher ID working as a foreign key in the relation subject. So this is the way by which we can establish 1:n relationship. Then binary m:(n), whenever there is m:(n relationship, we have to create a separate table for m:(n relationship, and the primary key of both relations will become the composite primary key of the relationship relation. That here you can see student and course are related to each other into MS2N cardinality, and we have to establish the relation. We have to create a new relation, that is enrolls, and the foreign primary key of the relation enrolls is the uh, student ID as well as the course ID, and it is a composite primary key. Then you can see binary MS2N course ID and student ID, student code, course code, enrolls, both are the component of the primary key as well as working as a foreign key. Then unary 1:1, whenever unary 1:1, the it is self-referential key, so the primary key field itself will become the foreign key in the same table. Here spouse is the foreign key, and again this comes the primary key of the employee code. Then 1:n, again the same will happen. A manager will become the foreign key, and where the primary key of employee number will take part in that relationship. Then unary 1:n, manager FK and employee kit primary key. Then unary MS2N, whenever MS2N relationship is there, we have to create a new relation. So we have to create a new relation, that is guarantee, and employee number will become the composite part of the composite primary key, where employee number is a guarantor as well as the beneficiary. So employee number will participate in two different roles, one is guarantor role, another is beneficiary role, and the guarantee primary key will be the composite primary key of combination of guarantor number as well as beneficiary number. Here you can see employee code is working as a foreign key in two different rules, one is guarantor, another is beneficiary, and both are the part of primary key as well as both are working as a foreign key. Then ternary relationship, whenever we have a ternary relationship, then we have to create a separate separate table for that particular relationship, and that is known as relationship relation. In that relationship relation, in our case here is the prescription is the relationship relation, here you can see, and whenever relationship relation is there, it must be composite primary key having the primary keys of all participating relation. So here three relations are participating: medicine, doctor and patient in prescription relationship. So the primary key of the prescription relation will be the composite primary key having the component from doctor number, patient number and medicine name. So it is composite primary key in the ternary relationship. Here you can see the similar thing, and all primary keys are working as a foreign key also, and these all three primary keys are creating the composite primary key of the prescription. Thank you. With this we will close the conversion of ER diagram to relational model. Thank you.